Yeah, hello. Welcome once again. Today we'll be looking at access control lists and prefix lists. So we'll take a detailed look on ACLs and afterwards talk about prefix lists. Just a, a kind of high level overview of how to use this and where it's important for us. So I'll grab my pen. Yeah. So I'll start with access control lists. The number one thing to note that access control lists on their own can do nothing. You just use it to match routes, and after the match, if it's not applied anywhere, it doesn't make sense. There is no need for it. So you have to apply it somewhere. That being said, access list one, they are a list of permit and deny statements. It's a list of permit and deny statements. By default, it has an implicit deny statement at the end. This implicit deny statement denies everything. Sorry about that. It denies everything. And the final keynote to take away from this is that access lists are processed top to bottom, and that the first match always wins. Okay. That being said, we have two types of access lists. We have one, the standard access list that will match. This guy will match based on maybe a particular host or a particular network. And two, we have the extended access list that this guy gives us more granular control. We can match a host or network going to another host or network. This guy is so granular. We can even start matching protocols. We can match IP, we can match TCP, we can match even some of the protocols, some of these protocols in the access list, as well as even layer 7 protocols like HTTP, Telnet, etc. All of these protocols, you can match them with what? Extended access list. This one is more granular. So depending on what you want to achieve, access list might the extended access list is always available for you to use in matching those networks. So what is the format for matching networks? by default, access lists, they match based on network bits. Keep this in mind. Don't forget that. So if we had the network 10.1.1.0/24 and we wanted to match this network to deny it, we are going to say IP access list. You give it a name. Say we say standard access list, we can give it a name. We can give it the name COD. Once we have given it a name, we can now give our do our deny statements. We can now say 10. We are going to match this network. And we are going to use wildcard bits to say 0.0.0.255. What this statement is saying is, make sure that the network that you are matching has 10 in the first octet, has a 1 in the second octet, and has a 1 in the third octet. Once you have that, I don't care what else, just perform this action. So it matches based on network bits. That is the simple thing about access list. And then you have to know that there is an implicit deny statement. Never forget that. This can ruin your matching, whereby maybe you are, when we start doing filtering, you have matched a particular network that you want to filter out and you forget the implicit deny. It is actually going to filter out all the routes, and we'll look at examples of this. In the case of a standard access list, we can say let me use the numbered one this time. Excuse me. Access list 101, and we can say deny 10.1.1.0. we give the wildcard math going to any HTTP network or going to any equal to 80. So we are even matching. Extended access list will allow you to match based on what? Port numbers. So extended access list offers us more granular control. But like I said, discussing about access lists and not applying them is not fun. So we get to play around with this much more in the next upcoming video, where we'll be talking about route filtering. Okay, we'll still look at a brief overview of access list in that video, but it's going to be much faster than this one. So that's the a high level overview of access list. I'll clear the screen here. Next on my list is prefix list. So for prefix list, the same rule holds, that it is also a list of permit and deny statements. Like access lists, they are useful, they are useless to us unless they have been what? Applied. They are useless until they have been applied. Also, like access list, it is processed from top to down. Actually, prefix list look so much like, if you get access list, getting prefix list will not be so difficult. And then there is also, like access list, there is an implicit deny statement. At the very end of the list. So this is Cisco that put it there. It's not you that put it there. That implicit deny statement is there by default. So remember, when we talked about access list, we said that access list, they match based on network bits, whereas in the case of prefix list, it's a double check. Prefix list actually match based on the network bits. That's one. And two is the what? The subnet mask. So the difference between prefix list and access list is that access list do this double check, and also the prefix lists match only routes. All right. With that being said, if I had a network 10.0.0.0/24 that I wanted to deny, for prefix lists, the format is, we will say IP prefix -list. We'll give it a name. Let's call it COD. And then we can now say deny 10.0.0.0/24. When you have this kind of thing, this one is matching only based on the network. But prefix lists have another thing altogether that can include in this statement right here. So I'll take this statement up here. In this statement, I have deny 10.0.0.0/24. I have matched the network. I can also say for subnet max that is less than or equal to 27. So now the prefix list will now do a double check. The first check is, do I have a 10.0.0.0 in the first 3 octet that is matching a/24? So for instance, if I had a network like this, 10.0.0.0/29, this network will not be matched. This network will be permitted. It will not be matched because the first bit, which is this guy, is a match. That's the first the first thing, the first 3 octets is a match. But now the last one, less than or equal to 27, and 29 is greater than 27, so this will not match. But if I had another network down here, 10.0.0.0 slash 26, the prefix list will process it first by checking the first three octets, which is a slash 24. Do they match? Yes, they match. So this guy has been satisfied. Is the subnet mask also less than or equal to 27? Yes. So for prefix list, it is what? A dual check. You have the flexibility of doing what? A dual check. So that is really that about prefix list. A lot of prefix lists are really not, prefix lists and access lists are really not what you do a lot of theory on. Once you start working on them, you start to understand them better. So let's kind of do a bit of differences here. Let's say on this side we have prefix lists. Another thing I forgot to mention is that prefix lists actually are less demanding than ACLs on the processor. So this is heavier on the processor, on the CPU. This guy is lighter on the CPU. This guy can match both route prefixes as well as protocols. This guy only matches route prefixes only. This guy has a dual check for network bits as well as subnet mask, and this guy will only match based on the network bits. These are some of the differences that the two has. Let's actually try to separate this. Okay, so separate it, make it cleaner. All right, I think that is that for prefix list and access list. When we start, we'll go to the lab. In the upcoming video, we'll talk about AIGLP route filtering and access list, ACLs and prefix list we are going to use them heavily when we are doing this route filtering, as it concerns all IGPs, EIGRP, OSPF, BGP. Is the same thing. All three use ACLs and prefix list for their route filtering. So the more we do it, the more you get a glimpse of it. You get used to it and understand how it works and how it functions. So this will be that for this video. I'd like to thank you for viewing, and I hope this has been informative for you.